All right, so here we go with the Unit 3 review. Okay, so we're going to take a look at this first question here. So it says, consider the following code segment. Okay, so let's see. Whoops, sorry. There we go. Okay, so consider the following code segment. And we're not going to look at the question yet. We're just going to kind of go through and trace this. So I'm actually going to do this one as an example for you, and then in subsequent questions, you're going to practice kind of tracing through the code and answering these questions as well. So I am going to go ahead and trace through this. So we've got an integer here called quant, and I'm going to just go ahead and annotate this guy. Let's see. Here we go. So I've got an integer here called quant that I'm going to go ahead and annotate right here, quant, and then its value right now is 20. So I'm going to go ahead and write that in. And then I've got another one called unit price. And we're going to go ahead and label that unit price. And then that has a value of 4 right now. And then we also have another integer called ship. And we're going to label that. Oops. And that has a value of 8 inside. There we go. And then we have an integer called total that has not been initialized. So we're just going to draw the box, label it, and right now it doesn't have any value in it. So total is right there. Okay, so now let's go through the lines of code that actually do stuff. So we've got here, if quant is greater than 10, so right now I want to see what's inside of quant. So quant is 20. So this is really asking, is 20 greater than 10? So this is going to evaluate to true. So that means I am going to do what's inside of here. So I'm going to go ahead and execute this line. So this says unit price gets set to 3. So that means I'm going to erase this old value here. Right, that 4 gets lost. And I'm now setting unit price to 3. Okay, so I did that, and now I'm here. Now I have to check this if statement. It says if quant is greater than 20. So right now quant is 20. Quant, let's see, 20, is that greater than 20? That's false. So this evaluates to false, which means I skip this, right? This is false, so I skip what's in between these two curly braces. So I don't run this line. This one's outside of the if statement, so I'm going to run this line regardless. This says that total gets whatever this evaluates to. So quant right now is 20. So 20 times the unit price, which is 3, plus ship, which is 8. So 20 times 3, that's going to be 60. And then plus 8, that's going to evaluate to 68. Okay, so this gets stored into total 68 right here. Okay, so I'm if you're just joining us, I'm just demonstrating how you can annotate in order to track the state of variables in order to kind of go through code and trace it and to see how it actually, what the result of that code is going to be. Because you're going to want to be doing this as we go through these review questions. Okay, so now that I've shown you how to do that, let's work on some questions. So let me go ahead and clear this. And so you'll see the same code on this question. And what it's asking you is, what is the value of total after this code segment has been executed? So if you're paying attention, perhaps you remember what value I wrote inside of total. So at this point, you can go to your copy of the Pear Deck, go to your tab of the Pear Deck, and if you need to, you can trace through the code, but if you're paying attention, you might already know the answer. So go ahead, and once you know the answer, you can select either A, B, C, D, or E. And if you just joined us, I'll put that link in the Pear Deck, or the link to the Pear Deck in the chat. Okay, so if we were paying attention while I was tracing through that code, you'll remember that what we wound up with was what most of you answered here, 68. And if you missed that, you can always go back and watch the video that I'm recording right now as I traced through it to actually come to that conclusion. Okay, so on the subsequent slides, you'll actually be tracing through code on your own in order to answer these questions. So let's go ahead and go to that first one where you work through it on your own. Okay, so for this one, let's see, did I actually? I don't think I actually enabled you to annotate on this one. Give me 1 second. New prompt. Oh, drawing. Here we go. I want you to be able to draw. There we go. Okay, so on this screen, what you're gonna do is you're gonna trace through the code and keep track of the values of A, B, and C by annotating on the screen. I created a little table for you because A, B, and C will be changing a few times depending on what happens. And so what you're gonna do is you're gonna trace through this and you're gonna wind up with final values for A, B, and C. So I'm gonna give you a little bit of time to work through that. So I'll start you off actually. So this starts off as A being 1, so that's that line right here. B being 0, so that's that line right here. And then C is initialized to -1. So what you want to do is you want to trace through the remaining lines and see if A, B, and C change. So feel free also to annotate over here. So like anytime you see a variable like B, replace it with the number that it is. Like here, B right now is 0, so I'll put 0 above the B, and A right now is 1. So now you can actually see what those values are. Okay, so it looks like many of you are now done. So let me go ahead and show some of the answers that we have. So you can come back to our screen here. Let me go ahead and erase my annotations. Okay, so the answers that I noticed are the students that did really well on this. I noticed that you really took the time to annotate the code on the left here. And anytime an if statement was true, maybe you made a little symbol like, okay, that's true. And then if anytime that the if statement was false, you like kind of crossed out that code to kind of indicate that you wouldn't be running that code. So I really like that you did that. And so the final state of A, B, and C is indeed going to be 1, 1, and 0. Yeah, that is correct. So let's look at some of these other ones, and then I'll actually show you, I'll trace through it as well, just as another example if some of you need that. Oops, wrong one. I want to show more examples. So again, see, marking out any if statements that are false, just indicate that so that you don't make mistakes and accidentally run that part here. Again, crossing out that part here and annotating what the current values of your variables are, super important. Okay, so let me go ahead and I'll go ahead and do this really quickly in case anyone needs a quick run through of how to trace code once more. Okay, so we know that A starts at 1, B starts at 0, and C starts at -1. Okay, so that's just these 3 lines right here. Now I'm going to go ahead and I'm going to evaluate this statement. So I know that B right now is 0, so I can put that right here. And I know A right now is 1, so I can put that right here. So with this statement, if we simplify this, 0 plus 1 is 1, and then double equals, and then A right now is 1. So we're really just asking, is 1 equal to 1? And we know that's true. So that means that I am absolutely going to run this code in here. Okay, so what this does is it says increase B by 1. Okay, so B++ is short for B plus 1. Okay, so we're going to go ahead and say that B is now 1 because 0 plus 1 is going to be 1. Okay, so we did that. And this next one says C plus equals B. So that's the same thing as C equals C plus B. Okay, so C right now is -1, and B changed, right? So this is not -1 plus 0, this is -1 plus 1. And so that is going to equal 0. So C is now going to be 0, okay? So now when we go down to this if statement, it's asking, is C equal to A? So it's asking, is 0 the same thing as 1? Oh, that looks like a weird face. That should be double equals, sorry. Double equals A, which is 1. That is false. False. So that means that we skip this. We do not do that. And so we're at the end of the code now, which means that the final value of A is 1, final value of B is 1, and the final value of C is 0. Okay? So I think on this next question, I think this is where you actually answer. Yeah. So on this one, if we traced it correctly, we know that A is 1, B is 1, and C is 0. So the answer here, you can choose which option. Some of you are picking it. So between A, B, C, D, and E, which answer option would you choose? Oh, that's okay, Jordy. Just follow along as best you can. If you need to, you could just watch my screen if it's too slow. You can also try joining the Pear Deck on your phone. It might be a little bit faster on your phone than your computer. You would just go to, on your phone, if you want to do it that way, go to this website, joinpd.com. Oops. joinpd.com, and then you would put this what is it, the little keyword here, SVERZP to join. Okay. All right, so you all were paying attention this time, and you indicated that answer option D was correct. Awesome. Okay, so let's get ready for the next one. Okay, so on this one, yeah, no problem. On this one, I want you to look at the following code segment. You can annotate and keep track of the variables if you like, but what I'd like you to ultimately do is circle any of the if statements that are true, and if there's any if statements that are false, cross them out. So just like how I showed you some of the students were already doing, that's what I want us all to do now. So if there's any if statements that are true, you're gonna circle them, and any that are false, you're gonna cross them out. Give you some time to do that. Ooh, some people are using color coding. That's nice. Sky, take a look at that second one again. Take another look at that one. There you go. Ooh, I got a scribble drawing. Thank you, Kevin. Oh, it went away. All right, so it looks like, let's see, is anyone still working? Okay, it looks like we're all pretty much done here. I know a few of you aren't working because I know Jordy's having some tech difficulties. A few of you still haven't answered, but let's go ahead and take a look at some model answers here. So let's show some responses. And these students have decided that both if statements are actually going to be true. So both of the if statements are circled. So let's take a look real quickly at how we arrived at that situation, or at that decision rather. Okay, so we know that M is 8. So I'm going to just create a simple little, I like to use a T-chart sometimes, like this. I don't think they're really going to change. Usually you like to use a T-chart if stuff changes, but it's kind of like a simplified version of, drawing out the boxes with the numbers inside. So M is 8 and N is 3. So that means that when I evaluate this statement right here, what it's really saying is 8 plus 3 is greater than 10, which simplifies to 11 is greater than 10, which is true. So I know that I can circle that. Okay, down here it just prints M plus N, which is going to print 11. So it doesn't actually change these values. So m is still 8 and n is still 3. Down here it says if m minus n is greater than 0. So m still is 8, n is still 3. So 8 minus 3, that's going to be 5. So this is the same thing as asking, is 5 greater than 0? That is true as well. And so we can also circle this if statement. Whoa, that's a big circle. Or it looks like a potato. I drew a potato. So remember to draw your potatoes around your if statements if they are true, and to X out your if statements if they're false to indicate that they will not run. Okay. So any questions so far? Let me know if anything is unclear. So let's go ahead and see what I think the question is going to ask us, what actually gets printed out. So if that's what it's going to ask us, we know that this line prints out 11 and this line is going to print out 5. Now, what do you notice about these print statements? What kind of print statements are they? They're the kind that does what? Because we have these two different kinds, print line. Yeah, same line. So this one creates a new line and these print on the same line. So what are we actually going to see on the screen when both of these things print out? Yeah, we're going to see 11.5, right? So 115 all together. So knowing that, let's take a look at our answer options here. Oh, looks like I duplicated my slides. Aw, maybe I just didn't put that. Oh, okay, I put the answer options on the actual Pear Deck thing. I didn't put them on the screen. Okay, so knowing that, you can answer A, B, C, D, or E. And of course, we see our answer option is, oops, show responses, is answer option D. Okay. So again, annotating your code is going to be super important as you answer these multiple choice questions. I know it might be kind of difficult to do that when you are given your tests on a computer. So I would recommend that you have scratch paper when you are taking your tests. So if you haven't been doing that on our Unit 1 and Unit 2 tests, you should absolutely do that moving forward. Don't try to do stuff in your head. It's just going to lead to mistakes. And then if you're taking the AP exam this academic year, you can actually write on the test. I don't know what's going to happen if you can't take it in person. I don't know how they're going to, I guess it'll be online and you can just use scratch paper. But always, always, always annotate your code and keep track of it with pen and paper. Or in this case, this is like virtual pen and paper, I guess. Okay, I think we have time enough for another question here. So this one is a little bit more involved. So this question, it's saying that the code segment below, the int variable temp represents a temperature in degrees Fahrenheit. The code segment is intended to print a string based on the value of temp. The following table shows the string that should be printed for different temperature ranges. So this is what should happen if we have these different temperature values. But my question is, what actually prints out when temp is set to 30? So you're going to go ahead and trace this code with the value of temp is 20. So let me go ahead and put that. So pretend that temp is set to 20, or sorry, temp is set to 30. And I want you to trace through the code and see what actually prints out. And look at the table and see if that's what the expected output is. And be really careful when you are evaluating this. Notice that there's only one print statement. So this print statement right here, and it's not going to print until it's done with everything, evaluating everything here. Okay, while you guys are working, I'm just going to go ahead and just annotate some values here. Yep, that's all I want to do. Okay. Okay, so I see that we're kind of tied between two answers here, and that's kind of what I expected. So some of you say that the answer that's going to be printed out is cold, which is actually what we expect, right? If it's 30, then we're in this 31 and below range, and we actually want it to print out cold. Others here have said that instead of printing cold like we want, you're going to actually print out warm, which is unexpected, right? We expect cold, and some of us say we're actually getting warm printed out, which is unexpected. So does anyone want to kind of volunteer to explain why it's actually printing out warm? Why is it actually printing out warm instead of cold? Feel free to explain in the chat box or unmute yourself, either way. Because the code still reads the last else statement, making the weather to warm. Yes, the Exxon is actually, you're absolutely correct. So let's demonstrate exactly what's going on here. So the first thing that happens is we're evaluating this statement right here. So if temp is less than or equal to 31, so temp right now is 30, so this actually is true. So let's go ahead and mark that as true. And so weather initially does get set to the string cold, right? So right now it has that string cold, okay? So we did run this. So that means that we skip the else. Anytime an if statement is true, we skip the else, so we're gonna cross that out. But then this is another if-else block, so we have to evaluate it. We don't skip this. This is a completely different check. So this says if 30 is greater than or equal to 51, so that's not true. That is false, so let's go ahead and stamp that as false. Nope. So we're gonna go ahead and we're gonna draw an X through this. But since it has an else, anytime you have an else and the if statement is false, we automatically run it. So we're actually going to run this line right here. And what this says is set weather to the string warm. So that means we're gonna erase this old value here of cold, and we're going to change it to warm. And so when we finally hit this last line right here, when we're printing out the value of weather, right now weather has warm in it, and so in our terminal, it's gonna print out warm, which is unexpected, right? We expect it to be cold, but because of this faulty logic here, we actually get warm printed out instead. Okay, so now we can actually look at what the AP question was asking. Let's go ahead and go to the next slide. And the AP question was asking this. Which of the following test cases can be used to show that the code does not work as intended? Would it be temp is 30, temp is 51, temp is 60, or some combination of those. So we already saw that this test case shows that the code does not work as intended, but you might want to take a look at if these values also show that the code does not work as intended. So I'll give you a moment to check when temp is 50, 51, does that work? And if it's 60, does that work as intended? Okay, so let's check for the sake of time since we're at 1:34, and yeah, we'll end after this question here. So let's pretend that temp is 51. So let's check that. 51. So is 51 less than or equal to 31? No, that's false. So we're going to cross that out. So that means that we're going to set weather. I'm going to draw a box for weather. Weather is going to be set to cool. Okay, so this gets executed here. Then we're going to check to see if temp is greater than or equal to 51. And that is false. So we're going to skip that. And we're going to run this. Okay, so we're going to wind up with the weather is warm. Sorry for the sloppy writing here. Okay, so is that expected? Do we expect warm for a value of 51? Let's see. Oh, I'm sorry. I hang on. The value is 51, and I wrote 50 here. Sorry about that. Let's backtrack a little there. Okay, so what we should actually be checking is 51 greater than or equal to 51? That is true. Okay, so that's true. We're going to run this, which means that we are going to replace cool with moderate. Moderate. Okay, so that means that we're going to skip this guy right here. And when we print out weather, it's going to print out moderate. So for the value of 51, we can see that moderate is an expected value. So that is not a test case that shows that the code does not work as intended. This actually works fine. Okay, so answer option 2 is totally fine. Now we just have to test out this option where temp is 60. So let's go ahead and do that. Let's erase that. Okay, so now we're going to test when temp is 60. So is 60 less than or equal to 31? No. So we don't run that. Instead, we run the else clause. Oops, I forgot to erase this. And so weather gets set to cool. Okay. And then we have to check this one. So temp, which is 60, is that greater than or equal to 51? Yes, it is. So we're going to change that value, the weather value, to moderate. Moderate. Okay, so since this if statement was true, it means we skip the else. So once we print weather, we get the string moderate printed out. And if we look at our table, do we expect moderate for a temperature of 60? Yes, it's within this range. So that example does not show that the code does not work as intended. So in this case, only option 1 shows that this code does not work as intended. And so we would pick answer option A, which is 1 only. So that's how I would work through that one. All right, let me stop recording. There we go.